Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at Remote Site Wireless LAN configuration. We'll be discussing the wireless router, logging into the wireless router, basic network setup, basic wireless setup, configuring a wireless mesh network, NAT for IPv version 4, quality of service, and port forwarding. This episode is part of my series on switching, routing, and wireless essentials for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Over the next minute or so, we're going to go through the process of setting up a wireless router and creating a wireless LAN on that router. Here we have a wireless router from Cisco. This is one of those routers that provide multi-function, something you would have at home. It provides you DHCP, DNS. It has a network switch on the back. It gives you wireless access to the network. And it does some other network services. You turn around the back. On the switch, you have your on the back of your access point, you have your 4-port switch here. That's what this is. This is for your LAN devices. You could plug in PCs, desktop PCs on your network. You could plug in printers that connect into the network. This is for the configuration of your hardwired devices. Over here, this is your WAN port, your wide area network port. You plug your internet service provider into here. You have a cable modem, a DSL modem. Out of there runs a network cable. Into here, you plug that in. This is that orange cable where you plug in. You plug a cable into a laptop or desktop here on your local area network switch. This will allow us to go through the configuration pages to set this wireless network up on your wireless router. Once you have it configured, you have your laptop connected into that LAN port on the back of that wireless router. Go ahead and enter in the IP address of that router. Now, we're assuming that this is the default settings. We're assuming that you haven't done any other configurations. You've just basically taken this out of the box or done a hard reset on it. There are no settings on that device. Depending upon your router, that default IP address could be different. Most of the default IP addresses are either 192.168.1.1, or it could be at the end, it could be 192.168.0.1, or some version of that. Your documentation, quick internet search should be able to get you to that point. Once you're connected in, you type that in your browser, you open up, you get a web page, something like this. First thing I'll ask you to do is log in. Here we're going to provide our default credentials. For this device, it happens to be a username of Cisco and a password of Cisco. You go ahead, type it in, and once again, remember, this is the initial configuration. Once you type that in and click in login, first thing it'll ask you to do is change your password. First time you log in, let's change it to a more secure password than just the word Cisco. What we have to do here is we enter in our old password. Once again, that was Cisco. Here, let's enter in a new password. Up on top, they give you some guidelines on password complexity. It can't be the same as the username, can't be the same as the current password, must be at least 8 characters in length, have a minimum of 3 character classics, meaning uppercase, lowercase, number, symbol. Must have a minimum of 3 character classes. Here they give you a little password strength meter just to give you a rough estimate on how your password is doing. I kind of rely on those a little bit. They give you a good idea, but they aren't foolproof. Now, if you want to get around this and you want to use your own password that doesn't meet these requirements, you can check this disable box right here, but I highly don't recommend that. So I would leave this unchecked because you do want your wireless router to have a complex password so nobody can get in there, change the passwords, change the usernames, change what authentication is using. All of a sudden, you don't have access to your router anymore. Go ahead and click save. And how you know your new password is working is when you click on save, it will log you out and you'll have to log back in. Here, once again, notice we are at our IP address. We have some more information here. saying this isn't necessarily the first time we visited in this browser session. We enter in our username, and now look at the password. The password is that long length of that password you just set. Go ahead, enter in your username, password, and click login here. When you do that, it will bring you to the opening splash page. On the opening splash page, you can get some information and helps you set up your devices. They give you initial configuration or initial settings here. They walk you through a couple things to do to get your router up and running. This is for an end user. This is for a home user. So they give you some nice little guides here on how to help you do that. First thing we're going to do is we're going to click on networking on the side over here. And then we're going to look at our WAN settings. That's our connection from our internet service provider. First thing on top here is our internet connection type. What type of connection is our internet giving us? Most internet service providers today give you access to their DHCP server. You need to pull an IP address from their DHCP server in order to get your wireless firewall to work. That's what the top setting is. Some internet service providers may do it a little bit differently. They may give you an IP address and additional information to type in. That here is our static IP. We may have some different protocols we are using to interface with their routers and their systems that would fall underneath these categories. If your ISP is having you use these, there's a good chance they're going to provide you with some additional instructions on the fields to enter and how you fill that in. Once you have your internet connection type configured, we can go and say, okay, now in order for us to use that network, use the internet successfully, our end devices on our inside of our network, on our local area network, they need to have some domain name services. They need to be able to resolve names to IP addresses to get our network routing, get the web page across the internet. We do have a couple choices on how we use the DNS. First one is get it dynamically from the ISP. Most of the time in today's world, you take the default, you use what your ISP gives you. Now you could use a couple other ones. You could use an open DNS. That's a Cisco product. That's some of their DNS servers. Or you could go and say use these servers. And underneath here, there's a couple of fields right here where you could go in and enter in that. Google has a nice DNS server that you could use. That address is easy to remember, 8.8.8.8. They even have a secondary DNS, and that address is 8.8, and then the last two is 4.4. So 8.8.4.4 is their backup one. However you want to do it, but like I said, most of the time when you're setting up your home router, take the default of getting it dynamically from your internet service provider. Then, once we have that configured, we can go and look at some of our LAN settings. So over here on the left side, I am now underneath LAN and LAN configurations. First spot up here is the IP address that you're going to use to connect into the router. This IP address is this IP address you type in your web browser to get there. Most of the time, people keep it at the default settings. Here, 192.168.1.1. Changing it could have some complications, so make sure you know what you're doing when you change that IP address. Part of the services of this wireless router is to provide a DHCP service for the devices on the inside of your network. It's to hand out IP addresses for all of your clients inside of your network there. And once again, this is like your home router. And at home, you have a couple desktop PCs. You have a gaming system, maybe some IoT devices like a Google Home or Amazon Alexa. They all have to get IP addresses to work. This is how they hand that out. And this is where the DHCP server is. And if you're using that, make sure enabled is selected. Now, if you're going to use somebody else's DHCP server, meaning you run your own DHCP server on your network, you may want to go and then disable this if you have a different DHCP server. But for most people at home, you want to run your own. Next stop down here is our starting IP address. In our network, and so if we look up here, our network range is 192.168.100, right where the difference between the subnet portion changes from ones to zeros. So our network is 192.168.1.0. There's 255 possible addresses in there. and they go from 1 to 254. I guess technically 254 usable addresses. And you can hand out some of them. Sometimes you want to reserve some of them if you want to statically program an IP address in your network. You want to hand them out. Here, they start at 100. And so the first address it'll hand out is 192.168.1.100 is the first one going to hand out. Now, the maximum number of DHCP users, meaning it'll hand out 101, 102, 103, all the way up to 100 IP addresses. So that would go all the way up to 200. You could have up to 200 devices in your network. For most people, traditionally, that should be a good enough number. But with how we start seeing all these devices needing IP addresses and being on your network and being able to communicate, especially if you get into some IoT stuff. And I mentioned like the Google Homes or the Alexa devices where you can say, hey, Google, turn off the lights, and it will do it. All of those devices need IP addresses, and all of a sudden you're using more than 100 IP addresses. For me personally, if I was to set this up, I would set my starting IP address at about 25, and I would say hand out 200 IP addresses. Gives me a couple at the beginning, gives me a couple at the end I can manually start in, but I have 200 addresses I can hand out. And on my home network right now, I'm at about 70 to 80 IP addresses I use on a regular basis. And so I'm starting to run out there. And then once you enter this information in, here it's just confirming to make sure you typed in your numbers right, that you're going to hand out 100 to 149. This started out at 50, but it got changed. And so it will say 199 after we click save. The client lease time here is 1,440 minutes. 1,140 minutes is 24 hours. So your lease time is 24 hours. They will lease that out to you. And if you don't say, hey, I want to use it again tomorrow, they're going to return that address to the pool and you can go ahead and reuse it. It's up to you on what you want to set your lease time. It says it has a range here from 1 minute all the way up to 10,000 minutes minus 1. And so it's a big range. A lot of times keeping it the default's way to go. I personally, because I like to play with network stuff at home on mine, I have this down to about 5 minutes, which would, should be about 5. I'm used to it sometimes saying seconds for lease time, but on my home network, I have it 5. Yes, it's going to generate more traffic, but as I put stuff on the network, take it off, it will adapt quicker. Then the next part of this DHCP server is, what DNS server am I handing out? We got a couple choices here. We're going to say use this as a DNS proxy. And what that means is your wireless router is going to make requests on behalf of end devices. And that hopefully eliminates some of the traffic on your network, because if it made a request for one DNS entry and another IP address on your network requests that, it'll just check its local cache, and so you have less traffic. But you could go and say just use all of the DNSs from the ISP, and then so we're always going to be querying the DNS server, which generates a little bit more traffic, but with the broadband connections nowadays, it probably really won't affect you. Or once again, you could go in and statically say use these DNSs. I hope you're liking this episode on Remote Site Wireless LAN configuration. If you have the time, please leave me a comment and let me know what you think about Remote Site Wireless LAN configuration. You can also visit my website at KevTechify.com for all of my details and how to get all these episodes in video and podcast form. We've looked at our WAN settings, our LAN settings. Now let's go ahead and look at some of our wireless settings. Well, what I did here is on the left side, I clicked on wireless. And now we are on the basic settings area. Under basic settings, this is the settings that affect your entire router to start with. First thing is we have our enable button. You can go ahead and check that, uncheck it. Unchecking that turns off your wireless. So if you got to turn off your wireless for some reason, quick way to do that. Or maybe you're at a point where you don't want to use the wireless on this device. Maybe you have a different device. And so this device doesn't work as fast as the new fancy one you bought. but you have everything set up on here, and so you want to use this just as a router and a DHCP server, you could disable the radio on here and then use the radio on your new wireless router, the one that's faster, has faster wireless. You could use that one, and so I've seen that. Then you get to choose the network mode. This router supports BGNN. It may sound like BGNN is the way to go, and that would be great if you have older equipment. By including the B with the G and the N, it's going to slow down your overall throughput because how those are all backwards compatible, how they have to work together. If you go, and typically I go with the GN mixed network for myself, that allows me to have the 2.4 gigahertz, which if you're getting in into a lot of the IoT stuff, you need to have a 2.4 gigahertz band available, but it is a lot quicker than the B. And so this is the one I typically choose, is the GN mixed here. Now you could go B only, you could go G only, you could go N only, you could go BG mixed. It's up to you. It's up to your situation. If you leave it on the BGN, you could be sacrificing some speed. I typically use the GN mixed. Once we have that set, we go down to wireless channels. And we talked about how the wireless channels covers a range of frequencies. And in the 2.4 gigahertz, there's basically three ranges that don't interfere with it. Three channels that don't interfere with each other. That's 1, 6, and 11. If you want, you can go in there and pick your own range, or you can pick your own channel to use. It's up to you which one you want to use. You can go in there and manually do it. But if you leave it on auto, what auto is going to do is the access point itself is going to go out and poll, and it's going to see which of the channels are the least congested, which is going to give you the best throughput, and it's going to pick that one to use. My recommendation and what I do for a wireless router is I leave it on auto because it goes and it selects the best one for you. Now, if you want to set it on one particularly, you can go down there and choose whichever one you want. And like I said, you most likely want to pick 1, 6, or 11 as your channels. On the bottom, we have a wireless table. Here's our wireless table. This lists all of the SSIDs our wireless router is currently broadcasting, and currently depends if it's turned on or off. But your wireless router, depending upon which it is, this particular Cisco wireless router, it can broadcast multiple SSIDs. It can broadcast multiple networks. When you take your smartphone, you say search for wireless networks, it can broadcast multiple networks, and you can set them up differently to provide different types of access. There are 4 networks, 4 SSIDs set up. One is the Cisco SB1, Small Business 1, Cisco SB2, Cisco SB3, Cisco SB4. There are 4 that come pre-configured for you to use. Currently, only one is being used. That is this one. And notice how it says on as our choice right here. That's the only one that's on. The other ones are disabled. They're not being used at this point in time. You can go in and easily edit these settings. You can go in and change the names, the different security modes, fairly easily on these devices. What you would do is come up here, choose, put a check in the checkbox right here for this network. It'll highlight it, and then go ahead and click one of these buttons down here, depending upon what you want to do. You want to just do a general edit. You can edit the security mode, do some MAC filtering, look at the time of day access, or edit the WPS. What we're going to do is we're going to make sure we check this first SSID here, and then we're going to click on edit. When you click on edit, notice the line turns green, and instantly some of the fields become interactive. You can go in and can change that. And so let's go ahead and change the first wireless network, the first SSID, from Cisco 1SB into Cisco Connect, or Business Connect. Just to give us a different name to show us how we're doing that. Here you can say, do I want to broadcast my SSID or not? Do you want to make it easy for somebody to connect to, or do you want to difficult them? And what this does is if you uncheck this, when you do a search on your smartphone, that network won't show up. But you can manually go in and put the name of that and specify the security settings. You can say what VLAN this connects to. These routers allow you to connect to different VLANs. That means you can have multiple different VLANs to different wireless networks on your device. This WMM here has to do with streaming. And this wireless network, this SSID, when checked here, will give priority to streaming services. What that means is when you're streaming a movie from the internet, it'll give you that service priority getting through there. You can also modify the number of clients that are allowed to connect to this network. Here we have 60. We could easily change that to something like 40. Once you made all your changes, what you do is you go down here, click save. When you click save, these fields become not interactive, but your settings will have been changed. We changed the SSID. We changed our max associated clients to 40. That's how we go in and configure that. Next, let's go in and change the security mode. Once again, make sure that you have the SSID, the network selected that you want to choose, and we'll go down here and click on Edit Security Mode. When we're in there for Edit Security Mode, you can choose what you want. Here we have the different variations of security, from disabled, meaning it's an open network, it's not going to require any authentication. We can put in WEP, but please don't use WEP. It's easily cracked. It's very insecure. Then we have WP and WPA Personal and WPA Enterprise. Once again, WPA is considered insecure in today's world. It is crackable. Most people use some version of WPA2. Now, this being a home router, this being something you're going to set up, you probably want to keep it on WPA2 Personal. You don't want to keep it on WPA2 Personal. WPA2 Mixed allows some of that older encryption. It allows that AES and TKIP. It's more insecure. That encryption method is a little bit more insecure. You just want to stay using WPA2 Personal. What this also does is the WPA2 Personal uses the stronger AES encryption, but WPA2 uses this pre-shared key. PSK, you'll see this a lot of times. Maybe it'll be listed as WPA2-PSK, pre-shared key. And that's just a password or a passphrase that the user has to enter in to get access to your network. Now you can go ahead and type it in here. They give you a rating on how strong your password is there. If you think you typed your password in correctly but not sure, you can go ahead and check this box right here, and that'll show it in clear text like it is. So this box is checked. We can now see what the password is. Otherwise, it'll show up in asterisks. Once you have those settings done, you can go ahead, click on save. When you click on save, it's going to upload and process it. This is the thinking screen. And it sits here for typically a couple of seconds. When it's done, you get back into the basic settings window. Here we're looking at this. We have our Business Connect we said earlier. It's WPA2 Personal. And we did set the max clients up to 40. Once you have that set, then you can go ahead and connect your end device to that. Go down, open up your Windows connections. It will be listed here. We can see that our Business Connect is now an advertised network. That's what we set up right here. Whoops, right there. We are broadcasting it. We can see it. When you click on connect, it's going to ask for our password. This is the password we entered. Now it's showing it in clear text because the mouse is over this little eyeball here saying show my password to make sure I typed it in correctly. Go ahead and click next. When you click next, have the right password in there. You will get that you are connected to your business network. Sometimes you want to extend your network. extend your network without having to run additional wires and that type of stuff. Some access points, in this access point from Cisco, this wireless router from Cisco allows you to create a mesh network. It's extending your network. And what you do to create this is you create, or you have multiple access points here, you set them up, but then you go and you have identical settings. And so between this one, we're using WPA2 with a pre-shared key. Pre-shared key is going to be the same. Notice our SSID is OfficeNet on both of these. That's there. But what you need to do is make sure you have a different channel specified. Once again, the channels you should be using is 1, 6, and 11. And you specify these to extend the range out. And then that's how you build the mesh network. To the end user, it looks like you have the same SSID, same password, same encryption, but you are actually using different channels to extend that out. Now, each one typically gives you maybe 50 feet or 100 feet depending upon your environment, but it is a nice simple way to extend it out using a mesh network. One of the big key points for a wireless router is the idea of network address translation. What this does is it allows you to use one public IP address, but yet service all of those devices on the inside of your network. If you weren't able to do that, you would need to get a public IP address for every device on the inside of your network. That would be not only be costly, but it would be very confusing after a while, keeping track of that. And oh, I turned this computer on this day. I have to use that IP address there, but I can't use that IP address. It starts to be very confusing. What NAT does is it gets one IP address from your internet service provider so they can route traffic to you. And then that router, it looks and says, okay, this internal device made a request at this IP address, and it sent it to the default gateway, which that wireless router is, and then that wireless router on behalf of that client makes a request across the internet. Because it has that one public IP address, that request goes across the network, internet, and it gets processed. So maybe it's a web page request. It's processed, it gets sent back to the public IP address of your wireless router. Your wireless router remembers, hey, I made a request to this address on behalf of this internal address, and it routes it back. And this allows multiple devices on the inside of your network to share that one IP address. It is a function of that wireless router. Some wireless routers also allow you to do what we call QoS, quality of service. That is prioritizing traffic across my device, across wireless, across that WAN connection. What this does is it says, okay, let's give a certain type of traffic a higher priority going across my network. If certain traffic takes a little bit longer to get there, it's unacceptable. Some of this would be something like an IP phone, where if you're in a conversation and it would be interrupted and there would be gaps in the talk because of static or traffic going across your network, that would be unacceptable. If you're playing, and here we got Counter-Strike, I know it's a little bit old, but if you got Counter-Strike and you want low pings, you want it to have a high priority on your network, you want to make sure it gets through your router the fastest, and you give it a high priority. So you give your real-time traffic, voice, video games, high priority to get through your network, and then you give other stuff lower priorities, medium or low. It's effective, because if you have to wait an extra half a second for your web page to load in, is that really a big deal? You probably don't notice it. You probably sit there, you're probably looking at the parts that loaded in, you're fine. But if you got a phone conversation that keeps cutting in and out, that's very annoying. And so you want to make sure you give the right traffic, the important traffic, what we typically call the real-time traffic, a higher priority to make your quality of life a little bit better. It was my pleasure to provide you with this wonderful episode on remote site wireless LAN configuration. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials for the CCNA. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.